I'm Miss Hearn. Let's get started. In this video, we're going to talk about how to find the sum of two vectors when we're given their magnitude and direction. I hope you find this video helpful. If you do, please give it a thumbs up. That will help other students find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos. So it's important to understand that vectors are used when we need to represent a quantity that has both magnitude, which means like size, and a direction. So for example, if you're pushing on an object, you're applying a force, a magnitude, and you're pushing it in a particular direction. And if two people are pushing on the same object, then we have two forces, each of which we can represent with a vector acting on the object. And it turns out that the combination of the two forces, which we call the resultant force, is very easy to find by just adding the two vectors together. But that's if you can write it as something times I plus something times j. In this example, we have two forces, F1 and F2, of magnitudes 30 pounds and 60 pounds, respectively, acting on an object. We would like to write these forces as vectors. What we know about them is their direction and their magnitude. The direction of F1 is north 10 degrees east, and the direction of F2 is north 60 degrees east. We want to find the magnitude to the nearest hundredth of a pound and the direction angle to the nearest tenth of a degree of the resultant force. So to find the resultant force is the same as finding the sum of the two vectors. But we need to write the two vectors in the form of something times I plus something times j. Now in the last video, we talked about how we can do that using the formula vector v equals the magnitude of v times cosine of theta I plus magnitude of v times sine of theta j, where theta is the angle formed with the positive x-axis. Well, first let's analyze F1. F1 is the smaller vector because it has only a magnitude of 30 pounds. F1 is in a direction of north 10 degrees east, which means that the angle formed between the north axis and this vector headed towards the east direction is going to be 10 degrees. But we want the angle between the positive x-axis and F1. So that's going to be 90 minus 10, or 80 degrees. Let's call it theta 1. So F1 is going to be the norm of F1 times the cosine of 80 degrees times the unit vector I plus the norm of F1 times the sine of 80 degrees times the unit vector j. But they told us the magnitude or norm of F1 is 30 pounds. So we can say that F1 is equal to 30 times the cosine of 80 degrees plus 30 times the sine of 80 degrees times j. Using our calculators in degree mode, 30 cosine 80 degrees is 5.21 and 30 sine 80 degrees is 29.54. Alright, now let's work on F2. What we know about F2 is that it's pointed in the direction of north 60 degrees east. In other words, the angle formed between the north direction and the direction we're looking towards the east is 60 degrees. So that means that what we'll call theta 2 is going to be 90 minus 60, which is 30 degrees. We were also told that the norm of F2 is 60 pounds. So let's use this information to find an IJ representation of the vector F2. So we have to multiply the magnitude or norm of F2 times the cosine of 30 degrees times I plus the magnitude of F2 times the sine of 30 degrees times j. So that's about 51.96 I plus 30 j. Now that we have both F1 and F2 written in this format, we can find the resultant force, F1 plus F2. Remember, all we have to do to find a resultant force is add the two vectors together by adding the coefficients of I and j. So F1 plus F2 is going to be 5.21i plus 29.54j plus 51.96i plus 30j. In other words, 5.21 plus 51.96i plus 29.54 plus 30j, which gives us 57.17i plus 59.54j. So this vector represents the resultant force. But how do we get the direction angle of the resultant force? How do we get the magnitude of the resultant force? The magnitude is the easier of the two to find, and we need to find it first before we can find the angle, the direction. So the magnitude is just going to be the square root of the sum of the squares of the two coefficients of I and j. So if A is 57.17 and B is 59.54, then the magnitude of this resultant vector is going to be the square root of 57.17 squared plus 59.54 squared, which is about 82.54. Now, to find theta, we're going to use this other form of the vector. We're going to use our knowledge that A is the norm of the vector times cosine theta, and B is the norm of the vector times sine of theta. So in this case, A would be equal to the magnitude of F1 plus F2 times the cosine of the angle theta that resultant force forms with the x-axis, and B would be the magnitude of F1 plus F2 times the sine of theta. But we know A was 57.17, and we know the magnitude is 82.54. So that means that the cosine of theta would have to be 57.17 over 82.54. This means that theta is going to be the inverse cosine of 57.17 over 82.54. So theta is approximately 46.2 degrees. Now we could have also used B. Either way, we get the same angle. So the resultant force has a magnitude of approximately 82.54 pounds and forms an angle of 46.2 degrees with the positive x-axis. If we want to put this in terms of directions, we have an angle of 46.2 degrees with the positive x-axis, then we're looking at north 90 minus 46.2, or 43.8 degrees east. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.